In this video, we're going to give a brief overview of exponential functions and their asymptotes. So this is going to be a quick review of kind of what we know about exponential functions and their asymptotes. So when we have a basic exponential function, and what I mean by basic exponential function is a function that's in the form of y equals a times b to the x. So we've got a little bit more layers now that we've done a few more things with exponential functions, that sometimes we have that a out in front instead of just our b to the x. So this will have an asymptote at y equals 0. So again, that's also the x-axis. So that base exponential function is going to always have its asymptote at y equals 0. So in one of the videos, I talk about how the asymptote and the y-intercept are one unit apart. That is true when we just have y equals b to the x. When we add that a out in front, that stretches out our function a little bit, makes it a little bit taller, or squishes it down and makes it a little bit shorter. And that's going to move where that y-intercept is, but it doesn't move where your asymptote is. So that remains the same. And one of the things you can look at to figure out where asymptote is going to move, if it moves at all, is if you do a shift. So the asymptote only moves if we shift the function up or down. Up or down. So if we have a function a or y equals a times b to the x and then plus some number c. This plus c, that is going to be our location of our asymptote. So y equals c will be the asymptote. So let's take a look at a couple quick examples here. And we'll look at where the y-intercept lands and where the asymptote is, and again, how we can see that from the equation. So the first example that we have is that we want to determine the asymptote of the exponential function f of x equals 2 times 3 to the x, and we want to sketch a quick good enough graph of this. So one of the things that I do usually like to do when I'm graphing any function, exponential or not, is to actually find the y-intercept, because that kind of gives me sort of a grounding point on my graph, and it just gives me a point to go off of. It's a point that's easy to find. We just have to plug in 0 for x, and we know that the point 0, 2 is on our graph. So drawing in our graph, we know that that's a point on our graph. Now this function, 2 times 3 to the x, that is one of our basic exponential functions like we were talking about right up here. So its asymptote is going to be at y equals 0. So notice it is now 2 units away from where our y-intercept is, and that's because it's got a stretch to it. And so we draw that in as a dotted line, kind of try to draw it in just a little bit above the axis. And I do usually like to label it. Same thing, I also tend to like to label my asymptote, not my asymptote, my intercept. And then we can draw in our graph. And again, we're just drawing a good enough graph, so we're getting that shape. We see our asymptote, we've got our y-intercept. That's perfect. Another way that I've seen students sort of think about that asymptote and think about the ones where the asymptote is at y equals 0 is that we can view this as having a plus 0, that we didn't move it up or down. And so 0 is where our asymptote is. So that's one way that you can think about that, but that asymptote's always going to be whatever is added or subtracted on that sort of base exponential function. And if there's nothing added, it's a 0, so that your intercept is at 0. So when we have things like we were more used to seeing in about week 3, 3 to the x minus 5, when we're getting an asymptote of that, that one is one that we shifted down 5 units, and our asymptote is going to be at y is equal to -5. Let's get our negative in there. And our y-intercept, again, I usually like to find that. Again, that gives me that sort of that grounding point on my graph and helps me just draw a nicer picture. So let's see, 3 to the 0 is 1 minus 5, and that's -4. So we know that the point 0, -4 is going to be a point on our graph. And we don't have that number out in front of our exponential like we have with the 2. So our asymptote and our y-intercept are going to be 1 unit apart. So our good enough graph. Let's see, there's our y-intercept. So 0, -4. Our asymptote is down here at y is equal to -5. And we want to skim along that asymptote and then go grow exponentially as we go past that y-intercept.